The universe is written in mathematics. Every law we've discovered, every force, every particle can be described with equations. From gravity shaping galaxies to quantum fields flickering at the smallest scales, mathematics doesn't just describe reality, it predicts it. Nerve, long before we observed black holes, equations implied they must exist. Long before we measured gravitational waves, mathematics suggested space itself could ripple. Again and again, abstract symbols written on paper have revealed truths about the physical world. But this raises a deeper question. Why does mathematics describe the universe at all? Mathematics is abstract. It doesn't exist in space, it doesn't evolve in time. It has no mass, no energy, no physical form, and yet it maps onto reality with astonishing precision. Why should this be the case? One possibility is that mathematics is something we invented, a tool created by human minds to organize patterns we observe. In this view, math is like language, useful, flexible, but ultimately constructed. But there's a problem with this idea. If mathematics were purely invented, why does it work so well beyond what we observe? Why do equations predict phenomena no one has measured yet? Why does the universe obey structures we discovered, not designed? This leads to another possibility, that mathematics isn't invented, but discovered, that mathematical truths exist independently of us, waiting to be uncovered. In this view, mathematical structures are real, not physically real, but fundamentally real, existing outside space and time, and the universe is one of their expressions. This idea is known as mathematical Platonism, the belief that mathematical objects exist whether or not anyone observes them, that equations describe reality because reality itself is mathematical. Some physicists take this even further. They suggest that reality isn't just described by mathematics, it is mathematics, that particles, forces, and fields are manifestations of deeper abstract structures, that the physical world is a kind of shadow cast by mathematical form. If this is true, it changes how we think about existence itself. Reality would not be made of matter, but of relationships, patterns, structures, symmetries. But this raises new questions. If reality is mathematical, why does mathematical structure exist at all? Why should abstract form give rise to physical experience? Why does mathematics feel timeless, while we experience time unfolding? At some point, explanation reaches abstraction so deep it begins to blur the line between physics and philosophy, between discovery and interpretation, between reality and representation. We use mathematics to understand the universe, but mathematics also shapes what we are capable of understanding. It defines the questions we can ask and the answers we can recognize. Perhaps mathematics works because reality is structured, or perhaps mathematics works because our minds are structured to see it. Either way, the relationship is profound. The universe behaves mathematically, and we are the beings who can read its equations. Is reality made of mathematics? We don't know. But the fact that abstract symbols can describe physical existence remains one of the deepest mysteries we've uncovered. Not a conclusion, not an answer, just another question waiting at the edge of explanation.